used to work at Autodesk making 3D tools. I made Meshmixer, if any of you are familiar with that. And I left there last October to make 3D tools at my company, Gradientspace, and I'm making VR 3D tools. And I'm going to talk about that. But I'm going to start with something a bit higher level. This is something that you hear a lot about. Is VR going to be the next big computing platform? This isn't from some tech website. This is from Goldman Sachs. People want to know this because the next computing platform is worth hundreds of billions of dollars. But what do we mean by that term, computing platform? These are both computers. They both play games. They both are very successful. But only one of these is a computing platform. Because when we say computing platform, I think what we really kind of mean is maybe like app platform. And when I say app here, what I mean is everything that isn't kind of entertainment, right? Not games, not movies, all that other stuff, the things you use on your phone that solve problems, let you communicate with people. Those are apps, right? How are we doing in VR app world? If you go on the Oculus store, you go to the app section, it's pretty thin. You've got basically media players and 3D viewers, which are entertainment things, and you've got drawing tools. Drawing tools in VR are awesome, right? We all have tried them. Drawing tools were awesome on tablet PCs too. So I had a tablet PC. It was great. I really liked that tablet PC. But the thing about tablet PCs was outside of drawing tools, we basically were using apps designed for a mouse with a pen, and it wasn't good. There are people who do this now in VR, right? They sit in VR with their headset on and they use a Windows desktop. This is these people really love VR. I can't do this. But this is kind of like using a tablet PC, using a mouse interface with a pen. With the iPhone and other mobile devices, what happened was we couldn't use those same software tools. We had to rewrite all the software so that you could use it with a finger. We couldn't, there was no crutch of having the old software work with a new input device. So, every time we've had one of these computing platform switches, we've had new input devices. Most of you are, I think, looking around the room, too young to remember that originally computers only had keyboards. And then someone invented the graphical interface and we got mice. We had to rewrite all the software to use this new device. Then we got mobile devices. We had to rewrite everything again to use our fingers. What do we rewrite all our apps for in VR? What's our input device? So this is one option. I don't think this is a good option. I think this is kind of like a mouse for VR. What are you doing with your other hand, first of all? This isn't taking advantage of most of what's in VR. I feel like that device plus VR headset is basically tablet PC. This is a bit of hardware math. It doesn't sell it, in my experience. We've also got hands, like HoloLens has hand tracking. Hand tracking is getting really good. The Kinect had really good body tracking. Remember all those amazing Kinect apps? It's really hard to use this data as someone who makes these apps. How do you use 3D hands to do things like simple stuff like clicking? You have to suddenly implement complicated gesture recognition. It's really hard to build apps on these kind of interfaces. They're good for games. Even those little clickers are good for entertainment, but it's hard to build complicated software. I think the action in VR and AR is going to be these kind of controllers. I think these controllers are incredible. 6 degree of freedom tracking, a bunch of buttons and things like that. If you kind of sit down and think about it, I build software like things like Maya, 3D modeling tools, right? Where usually you use it with a mouse in one hand, the other hand on the keyboard for hotkeys. You need all of that input capability to operate the software. I think an Oculus Touch controller pair has more input power than a mouse and keyboard. We've never had that before. Multi-touch wasn't even close to what you could do with a mouse and a keyboard in these kind of tools. These, I think, are the most advanced input devices we've ever had for computers. Just the range of power they have, not just the 6 degree of input, but also all these other buttons and things like that. They're just incredibly powerful, and that's what I'm going to try and show you. The one amazing thing about them is that you have two. I just saw a tweet from someone in the VR arcade saying, why do you need two of them? You need two because you have two hands. And there's a thing you can do with two hands. It's called bimanual interaction. And this is something people in HCI research have studied literally for decades. This guy, he was actually just mentioned in the previous talk, Bill Buxton. He's very famous in this area. He was one of the sort of founders of human-computer interaction, his research field. He worked at Alias Research, he worked at Microsoft Research. Things like the Microsoft Surface, which is a bimanual input system, largely came about because of his advocacy at Microsoft. Here he's using two spatially tracked controllers. This is from 1999. He's not touching the screen. These are floating in space. They're only positionally tracked, right? And he's doing this smooth curve drawing where this is the second hand here. It's kind of hard to tell, but he's defining the tangent. So he can draw extremely smooth curves even though his hand is all wiggly and jittery because he's got two inputs. So I think this bimanual interaction is amazing. There's one of actually Bill Buxton's group at University of Toronto in, I think it was 1994. They invented something called the palette menu. They did it with two mice. But palette menu has been adopted in VR. If you remember, using tilt brush, or even early on, they had this idea that like, oh, you've got your menu, and over here you click with your other hand. You select things on this floating menu that's on your other hand. That's the palette menu, basically. And it works really well in this context. The idea is that you're kind of like a painter. You're like the VR Bob Ross. You hold your palette with one hand and you brush with the other because you don't usually paint with two brushes at the same time, right? It works really well for painting. But palette menus then kind of took off in other tools. Here's sculpting tools. They got round ones that are using palette menus. Sculpting you do often kind of use two hands though. This is not even really a sculpting tool. This is kind of just a 3D modeling tool. You're always holding that menu though with the other hand. They're kind of starting to get really complicated. This software is quite impressive, but it's got really a lot embedded in this one floating menu on your hand. At some point, it just doesn't scale anymore. How much stuff can I have on my hand? You're going to basically take your whole Windows desktop, subtract off this viewport, and put everything else floating on your hand here. That interface just doesn't, that's not sustainable. We can't have all our software work that way, I don't think. And in part because you're wasting that hand. We do things with two hands, Lego, sculpting. If you think about it, a lot of things happen with both hands, and now we have controllers that can use both of them. We should use them. And I'm going to explain to you with some examples why this makes a difference. This is software one of my clients, I'm building for one of my clients. This is a desktop app. So dentists use this to if you want to get braces, they use this to lay out your teeth, to plan ahead what's going to happen, right? So the teeth part they're just moving, but the main thing is that to do this, they have to use one of these 3D transform gizmos. Now, some of you probably use 3D modeling software. You're really good at using those. Dentists are not. So figuring out, these teeth aren't on a grid. There's no alignment. They have to use those axis controls to try and move the teeth around. It's really hard. It takes them a long time. In VR, so we built a sort of VR version of this app. They can just reach out and grab the teeth and move them. This is so much simpler. It's just it almost doesn't really, it kind of doesn't even register of course that's how you would do it. It's obvious. You've got these controllers. You would just reach out and do that. That was impossible until we had these controllers. The fact that you have two, so those teeth, remember, these are going to be physical teeth. They can't they can't go inside each other. So you have to position them so they're not intersecting. They have to actually position a whole sequence of teeth movements. It's really hard. With this VR interface, it's really simple. They can do simultaneous positioning. They don't need any training. They had this at a trade show. The dentist would put on the headset. He would move the teeth. They didn't have to do any training. It's obvious that's how you would do it. It's faster. There's not as many more operations. In VR, the teeth are enormous. They're like this big, right? And the scaling on the input is there's a quite high rate control. So it's about 10x. So you can do extremely small movements with those controllers. So for this task, for this app, VR is better. It's not just like a different interface. This is at least an order of magnitude better. This is a better way to solve this problem. So I think this is something that, that's one example that we're doing. But I think there's a lot of examples like this. And I think there's going to be more and more when we start to really do it. We have to build the apps, though. You have to start building them. You have to try building them. The thing about building apps in VR is that it's really hard. So, if you want to build desktop apps, you've got things like AppKit or WinForms or Qt. This is like software-level components. On mobile, we have the same thing. On VR, we don't really have these things. We don't really have these 3D app frameworks, which are kind of like, they're kind of like the infrastructure for your program. So we can't use the 2D ones because VR apps are 3D apps. We can't use the 2D app frameworks. Game engines, they don't really solve this problem. To do that in a game engine, you have to implement a lot of complicated stuff that normally the app developer doesn't know those things. You need this in-between part, this app framework. And that's a normal thing. When people build you a mobile app, they don't build the whole thing. They just build on top of these frameworks. And we basically don't have one for VR. So that's what I'm working on. So we have this application framework. It's called Frame 3. So this is built on top of Unity right now. We're working on abstracting that. It's C#. It's open source. It's completely free. It's MIT license. You can use this, do your own stuff with it. It supports VR. It also supports desktop and mobile, because I think one of the ways we get people into these VR apps is by having this easy transition from desktop apps to VR apps. And so you can build an app in desktop or in VR and then kind of lay out the VR UI for desktop app. It has all sorts of stuff in it, like 3D transformations, undo and redo. It's got this 2.5D UI system I'll show you. And I'm going to show you some complicated apps built in that, but this is a really simple one. I did this in an hour. I wanted to just have a demo of like an easy app. So this is like a little photo sorting app, right? It loads in photos from a directory. This is all the code for it. If you're like a coder, it's really not very much. There's about, there's a little bit more further up. It didn't fit in the screenshot. It's about 100 lines total to do this moving stuff around, because the framework does most of it for you. So now I'm going to, for the rest of the talk, basically, I'm going to talk about in this frameworks, what are some of the challenges we have to build apps in VR? So this isn't about building VR experiences or entertainment. This is about building software programs, right, that people would use to solve problems. I think they probably are useful in those other contexts too, but that's not what I'm really thinking about when I'm designing these. So the first problem is moving around in space. If you've ever used desktop 3D tools, if you use bad ones, you know that like when you want to look at the thing from different views, you rotate it and suddenly it's upside down. And you're like, how do I get it back? That's because that's the easy way to do this kind of stuff. There's better ways, like in software like Maya, good 3D software. There's something called turntable where no matter what you do with your mouse, it always goes back to being upright. In VR, we're still kind of in that first stage where like we haven't really figured out how to do all this stuff. Like the straightforward way is like, well, you just grab the thing and reposition it with your hand, but then it's tilted, and then how do you get it back? This has obviously got a bottom, but it's going to be angled when I do that, and I can spend a lot of time trying to get it upright again. And that's a single-handed kind of thing, right? There is usually, in these kind of tools, a two-handed gesture. It's kind of like pinch and zoom in VR, right? Where you use both hands, and you go like this, and the thing gets bigger or smaller. This isn't actually zoom. This is scaling the whole thing, which is different than zoom, and I'll explain. So I did the similar kind of interaction in this framework. But this isn't a zoom, this is a dolly. So in 3D tools, zoom means changing like the field of view of the camera. The camera doesn't move, the object doesn't move, you're just changing how it's rendered. But when you zoom in like a tool like Maya, you're actually moving towards the thing. So we implemented it that way, that when you go like this, you move towards and out, in and out of the thing. But you've got two hands. I mean, in mobile, you often have this two-finger pan gesture, so you can do the same thing. You move your hands simultaneously. You can also move them in and out, though, in VR. And then we did a similar kind of thing. We called that other one turntable. So your turntable, you're moving your hands basically like you're turning a wheel, and you can tilt it up and down. The thing here is because we've separated all the degrees of freedom, you can do this crazy rotation, and you always can get back to being upright. So it's very safe. There, I mean, you can see my hands are going like this. It's never going upside down or ending up in some crazy viewpoint. And you can combine these things. So I showed them there separately. But because they're orthogonal, you can do them independently. So here, this is this huge model that I can basically fly around in VR. And because I have total control over the speed, because the speed is mapped to my arm movement, this is super smooth. And I think actually the sort of connection between my large-scale body movements and this produces less nausea. And also, because you're using your whole arms and not just like your wrists or something, there's the thing called the biomechanical advantage. If you ever want to draw really smooth lines, you know that you draw with your shoulder because you can move smoothly then. So this is really nice. We also have that sort of rescaling gesture, because there I was just moving around this huge thing, right? If I want that thing to be smaller, I do this gesture, I draw out this ball, and here it looks the same because it's not in VR. But here's what it looks like, you know, from the VR perspective. That thing suddenly got much smaller. So we made it very easy to jump between scales. You can have a huge building, and then you want to work on it. You can bring it down so it's right here, do some things, send it back. And we try to make that really fluid, because in practice, when you're doing things like this, that is a huge difference to be able to very quickly do that. Just wanted to say this model is a super high-res scan from this company, Digital Life. They have amazing models. Some of them are on that model sharing site that has VR that I lost the name of now. It's the one that everyone uses, so you could check them out there. No, not TurboSquid. Sketchfab, yes. So I mentioned, I don't like this left-hand menu, right? But we still need interface stuff. It has to go somewhere. And so I always think about, if you've seen Iron Man, there are always these shots of Tony Stark inside his helmet, right? And he's got all these like UI things floating around his face. And they kind of track him when he looks around and stuff like that. This is what I want. I want this kind of UI. And if you think about it, is that right, like here in his face? It can't be in front. You can't see Ultron then if it's right in front. It has to be kind of on the side, right, that he's looking over at it. And is it right here, or is it maybe like a little bit further out? I mean, why would you put it right here? It could be out in space. So basically, I tried to implement something like this. So this is like a screenshot from kind of behind your head in VR, and then in 2D. So it's all kind of distorted. But that circle in the middle is basically the sort of viewport you can see in the HMD. That's the sort of black border. And so just on the edges of that, there's some of these like UI elements sticking in. And then outside of that, you have this user interface zone, right? And the way it works is you can look over here. You can't glance there, right? We don't have that wide of, it's in the periphery, but you can't actually see it because our circles are too small in VR headsets still. But if you look over there, you can look at it a little bit, and it stays put. So you can see here, I'm going to glance over to the left. It moves a little bit with your head, so you can kind of pan and you can crouch, and it follows you. But it doesn't move when you look at it. It couldn't. But if you move far enough, then it starts tracking you. So this system is basically like a kind of smart cockpit that's following you around. And once you stop moving, it locks in place. And then, so this is what it looks like in the VR view, kind of. I mean, it's best I can do in not VR. And so you can see here I turned around, and now that thing is tracking me. You can see it's just kind of on the edges. That's more or less what it looks like. And you can glance to some range and see it. So we actually call this a cockpit, like in the software. And we have a bunch of UI elements you can put into cockpits, like buttons and sliders and text fields and lists. I made a little file browser, so it's got like a text field and load buttons, and you can click on these things. It's got a push and pop system where you can push and pop cockpits, so you can change what you see in this overlay kind of heads-up display. It's got a bunch of automatic layout things. And I think actually having this like UI around you that's kind of stable, I mean, we know from like racing and flying games that really helps. In flying games, I can do crazy stuff that if I try to do like a first-person game, I'm just going to puke right away. So I think this really helps actually with things like nausea. So those are two of the kind of UI problems we've worked on. And I'm going to show you just a couple like demos now of using this software I'm developing. It's called Simplex. And it's like kind of like a 3D tool like Maya, but in VR. So in my sort of tools, I tend to use, I don't use the controllers. You don't actually see controllers. You see these arrows. I find it a little bit weird to show the controllers. I feel like they're showing a mouse cursor that looks like a mouse. These controllers, these arrows, the tips of them are kind of offset, so you can actually use the tip. It's like a useful thing to have that tip of that arrow there, because you can put it on things. You can touch stuff in the real world without the controller hitting it. And then we have rays into the scene. We also have cursors that track the thing. Cursors are good, I think. Cursors are a good UI tool that if you want to be immersed, sort of have VR immersion, you maybe say like, we don't want cursors in the scene, but cursors are useful. They provide useful feedback. So I can tell here that this isn't hitting anything. You can't really tell the colors that much. Here, it's darker and solid. It's hitting an object now. Here, it's hitting something I can interact with because it's a different color. It's really hard to tell that this ray is hitting this thing. I can move my hand in lots of places where the ray is not hitting this box, and I won't know, but I can tell from the cursor. So you'll see in the videos a cursor. So here's a little demo. This is the scene I set up, and I'm going to basically snap together these pieces. So we have tools like capabilities like snapping and stuff like that. But you see here, I grab the object with one hand. I can use both hands to kind of pass it between each other. We don't have any inherent handedness in this whole interface. You can assign, using the sort of tool palette on the left, tools to each hand or capabilities so that you have this bimanual interaction. So this is a sort of bimanual assembly like you would do it in the real world. Here's another example. So this is like a basic measuring tool. I got to get in here. I want to measure this little thing, so I got to fly into the scene. I have no nausea when I do this. I don't know if I used to, but I don't anymore. I'm doing this measurement, but now I want to do this bigger measurement. It's too far. I can't really see it at the same time. So I'm going to go back out. I'm going to use that rescaling gesture. And the whole scene is going to get smaller now. Now this is kind of outside view, right? And now I can do that measurement because it's like right here. It's small now. Before it was the real scale. So I'll just mention something there, kind of technical thing. A lot of stuff in VR interfaces is based on ray casting because that's like what Unity supports and things like that. It's very hard to do things like hit the corners of stuff with ray casting. So there's another alternative, which is like if it's close to you, if you have a point, you can snap that to the nearest point on the object. That is a thing that doesn't come out of the box in most of these engines, but we've implemented it in our library, so that's available. And it really works a lot better for a lot of these kind of room-scale direct input interfaces. One other project that I work on is this project to make 3D printed prosthetics. This company, Naya Technologies, it's a nonprofit spun out of U of T. They make 3D printed prosthetics, and what they do is they scan what's called the residual limb, and then they model a socket off it. And this is a similar kind of problem to that dentist thing. The people who have to do this are prosthetists in Uganda. They are not using 3D user interfaces very often. And so they have a lot of problems learning this software. And so here's one example. They have to take this scan, and they need to just get this part of it. They need to get rid of all this other stuff. If you've ever had a 3D scan, you've probably had similar problems. So it's really hard in a normal interface. You have to use those gizmos and stuff like that. In VR, you just grab the thing. You've got this cutting plane in your hand, like tick, tick, tick. It's done in like 10 seconds. And that makes it so easy that it's like we can use this kind of thing as a modeling tool now. We would never have made a modeling tool that was just like based on, you have primitives, and you can just quickly do plane cuts to make more interesting shapes. Because it would take too long to move all those, do all that plane cutting. I mean, I've written software with plane cuts, and no one uses it this way because it's just too much work. So I think this is really interesting. We have this whole space of things we know how to do on computers in 3D, but that were too hard to do because we had to use these complicated user interfaces. And now we have new user interface capabilities, new user input capabilities, and we need to go back and revisit all those basic things and say, like, what can we do in this new space? Here's another example. In this prosthetic thing, they need to basically make changes to the shape. They need to select regions, and then they need to kind of push them in and out. And that selecting regions is really hard. Here, it's actually not too bad because the things are not too complicated. But one of the other things they have to do is they have to make this loop all the way around the top of the shape. And doing that with like a bunch of rotating and little drawing bits of curves is so hard, and it's so easy in VR. I wish I'd put it in the video, but I forgot. So this is just a kind of speed modeling demo of using this software, this Simplex software. And we've got a bunch of other stuff implemented. You can like draw tubes. You can do revolutions. You can draw curves. There's a bunch of snapping and primitive tools. I mean, this is super under development still. I'll give you a link at the end. It's very buggy. I will be totally honest. But I think it's really interesting. Like when I started working on this software, it was actually kind of just for fun. I was like, I'm not really sure about this whole VR thing when I quit at Autodesk. But I'm totally sold that this is better. I've been trying my entire, like I did my PhD actually in the DGP lab that was just mentioned also. I've done my whole career trying to make easy to use 3D modeling tools, and we basically just failed completely. Like they're not easy to use. I've built tools that are very popular, but they're not easy to use. And this is easy to use. Like it's not trivial, you still have to learn how to do some things in it, but once you know the basic stuff, the things you can do, doing these kind of 3D curves and complex sort of spatial manipulations is just so hard in the tools we have now. It's really cool, I think, that we can do this now, and you should do it too. You should build apps. Build apps, use two hands in the apps. You can build it on this framework that I'm developing. You can email me when you can't figure it out because there's not good documentation. So you can get it from our GitHub, Gradientspace GitHub. And Simplex is on the gradientspace.com website. So it's free, I would say it's crashy. If you just want like an OBJ viewer for VR, it can do that. It can import textured OBJs. We just added Janus VR export, so if you like Janus VR, you can make stuff and export it to Janus VR. And that's my talk. Oh, and I'm like perfect on time, too. Thank you.